Okay. We're going to talk about industrial safety. And then I'm going to go see if I can find the bills of material for the mechanical trainers. And for lab, we're going to go out and take inventory, anything we don't have. You guys get to find, source it. Tell me where we can buy it from so that I can get replacement parts ordered. So, you know, like Granger, McMaster Car, Amazon, Walmart, you know, wherever we can get them from.
Harbor Freight.
That's they have what we need. Yeah, any place that you can find the parts that we need, assuming we need any at all. But there are several different size pulleys and belts and gears and chain, and we may need pick up a couple extra master links for the chains, or you know, things like that. So reflective tape for the photo tachometer, things like that. But we usually end up having to replace it. I know there are a couple of the motor slides that need some new jack bolts on them. Anyway, industrial safety. Hello, clicker. My batteries are all right. My clicker don't work. Paper's on, so. Okay, I'll have to do it the hard way. Who wants to drive for me?
I'm sorry.
Who wants to drive?
Drive? No, I'll do it.
Advance the slide when you hear the beep.
Okay.
Okay, OSHA, otherwise known as the Occupational Safety and Health Administration, was created by the Occupational Safety and Health Act of 1970, or the OSH Act. A lot of people think that OSHA is the Occupational Safety and Health Act. It's actually just Occupational Safety and Health, OSH Act. Their mission is to assure safe and healthful working conditions for working men and women by setting and enforcing standards by training, outreach, education, and assistance. Those standards are 1910.132 through 138, and that tells you everything you need to know about PPE or personal protective equipment. ANSI, or the American National Standards Institute, was founded in 1918. It's a national organization that identifies industrial and public need for standards. It has over 125,000 companies as member institutions, and 3.5 million professionals belong to ANSI or work with or for. PPE as defined by OSHA 1910.132, clothing and or equipment used to reduce the possibility of injury in the work area, which includes but is not limited to arc-rated clothing. Anybody know why you need arc-rated clothing?
Welding, sparks, fires, electrical work.
Head protection, helmet. Eye protection, that can include something as simple as safety glasses, or potentially goggles, full face mask, arc blast hood, all kinds of things that you can do. Ear protection, earplugs or muffs. If you are in a loud enough environment, you want to do both. Hand protection, typically just rubber gloves, but if you're dealing with things that are sharp, you want the cut rated gloves. So, if you're a butcher or whatever, and you're constantly dealing with sharp objects, you use the cut rated gloves, and depending upon the rating of it will determine how much protection it gives you. Foot protection, at a minimum, steel toe. Depending upon what environment you're working in, you may also want the metatarsal guard that goes all the way up to your, across your foot and up to your ankle. I used to have to wear boots that had the metatarsal guard on it. And there's a couple of times where I actually dropped stuff on my foot. I was damn glad I had it. Because instead of smashing my foot and breaking it, it just bounced off. And the soles are typically made of neoprene rubber, which does not affected by oils. And then back protection. I'm sure you guys have seen the doodads that you wrap around your waist, and it's supposed to help your back. Head protection. Have three classes of protective helmets. Class A protects against low voltage shocks, burners, impact hazards used in construction manufacturing. When it says low voltage, it means up to 2,000 volts. Class B protects against high voltage shock, burn, and impact hazard, including penetration, usually used by utility services workers. Penetration means if something sharp falls, instead of going through your head, hopefully it's going to bounce off and miss you completely, but it may bounce off, hit you in the shoulder. Hitting you here is a whole lot less likely to kill you than if it hits you here. And then high voltage means that it is up to, like Brad said, 20,000 volts. Class C is manufactured with lighter materials that provides impact protection, provides no shock protection. Example would be just a bump cap. It's good if you are one of those people like me that stands up without worrying about what's above you, and you end up, that's what those are for. Could have used one at 1987, I think it was. Me and my best friend, who unfortunately passed away this past weekend, we were in my mom's car, and we were on our way from his house to his girlfriend's house. Well, I was sweet on her sister. So we're on our way, and it's just starting to rain. Just enough to get the oil to raise to the surface, and there was a dog the size of a small horse jumped out in front of us. And, there's the Plymouth Horizon, so the car was this big. And my immediate reaction was to go for the brake. Tried to save the dog's life. Well, that caused the back end to slide around. So I was learned how to drive in a rear-wheel drive vehicle. Rear-wheel drive vehicle, you steer into the skid, recover, and go. You don't do that in front-wheel drive vehicle. You point the wheels in the direction you want to go, and you mash on the accelerator. So since I steer into the skid, the car gets pulled in that direction. We went through the ditch. There's a fence. So went through the fence. There was a telephone pole sitting in the corner of this lot, hit the guy wire on it, snapped it, it went right around power pole or the power lines and shorted them out. Then that same fence does one of these numbers. So I went through the fence again. Right on the other side of that fence is a 3-foot drop. Well, as soon as the front of the car crossed that fence, gravity took over and it went like that. End over end. And then the second time it came upon his nose, for whatever reason, instead of going on over again, it fell over on the side and we rolled it. So planted it in people's driveway like this up against a tree. Well, he says, "You all right?" I said, "I'm great. You all right?" He said, "Yeah." I said, "Good, get out of the car." So he tries to open the door, and of course, you know, the car's all mangled, so he couldn't get the door open. "I can't get out of a hurry, mate. You gotta get on your side." Like, dude, this is the dirt I'm looking at here. We're not getting out on this side. Oh, yeah. So he gets up and starts beating on the door, finally gets it to open up. Climbs up out of the car. I stand up to get out of the car, and right about the time I got stood fully erect, he let go of the door.
Oh.
Armrest. Whacked me right on top of it. I would have given anything to have a bump cap that day. And then, of course, I climbed out of the car, called the cops, and it was an interesting time. Moving on, eye protection must comply with OSHA standard 29 CFR 1910.133 as specified in ANSI Z87.1 and would be applicable to actual safety glasses or prescription glasses as long as the lenses are ANSI rated to that standard, but then you have to have side shields. If you wear glasses that are not ANSI rated lenses or you do not have side shields, you must have goggles on over them or a face shield. Okay. Face shields typically arc rated, but don't have to be. Most of them are polycarbonate because it is impact resistant. Has to be properly maintained, which means you have to check them regularly for scratches, pitting, cracks. That reduces your vision and may lead to lens failure. Last thing you want to do is have something come flying at your safety glasses that are already compromised and either go through them or cause them to shatter and that go in your eye. That would not, either one of those, be a good time. Ear protection, OSHA 29 CFR 1910.95 defines what the permissible noise exposure levels are. It's what is known as a weighted, time-weighted average. Okay. If you are in an environment that is 90 decibels, you can do that for 8 hours without having to worry about hearing protection. If it was 92, you can only last 6 hours. 95, you can only last 4 hours. And when you get all the way up to 115, it is a quarter hour or less before hearing loss occurs. You get up around 130 decibels, and there is no limit. There's no exposure limit. If you're exposed to 130 decibels for that long, you're deaf. It will rupture your eardrums, cause them to bleed, and that sort of thing can potentially, depending upon how short the pulse is. You ever stand in front of the speakers at a concert and feel that bass? Yeah. That 130 decibels hit you in the chest like that, it could potentially rupture your heart. all realize that sound energy can be that powerful, but it absolutely can. Ear protection has a noise reduction rating, or NRR number, and is based off the amount of decibels that the device reduces from whatever the ambient is to what actually enters your ear. Noise level of 80 dB is considered okay for an indefinite period of time. Ear protection rating, protection rating of 20, you subtract 7 decibels for real world application. They really only have 13 dB protection. Reduce the overall decibels from 80 down to 67. Okay. Hand protection, 6 different classes. 0, good for up to 2,500 volts. 0 is up to 5,000, so on and so forth. The chart there, notice that AC voltage is less than DC voltage. Voltage is voltage, isn't it? So, if voltage is voltage, why would you have higher readings on the DC than you do on the AC?
What was it? I'm sorry, repeat that last part.
Why is the DC volt rating on the gloves higher than the AC?
Because it's steady. Because direct current.
Hey, what's that got to do with it?
It's AC
I
voltage
remember this
alternates.
Okay. What's that got to do with it?
Not 100% sure.
DC current easier to stop than AC current?
No. It's the other way around.
Oh. I want to say that the more it's gonna take more electromotive potential for a DC current to I want to say you know how certain materials, all materials can become conductive at any voltage.
Voltage is high enough, yeah.
Yeah, it's usually higher for, usually electromotive potentials have to be higher for DC current. I forget exactly why, but for most materials, there has to be higher electromotive potentials for DC current than AC in order for the material to become conductive, hence the reason why.
Okay. Why?
I forgot why, come on. Oh my goodness, I'm sure it's in. Shoot.
Bill, Devin, you guys were just in
I feel like we just.
basic electricity last semester.
Yeah, I was in that class with him.
Yeah. You're the one struggling. I'm hoping one of these two guys can bail you out.
Remember that DC voltages were higher, or had to be higher for the material to be conductive.
Because DC is more constant?
No, it's not. No. Oh,
Did you just have an epiphany?
kind of. So, remember, you know how charge is composed of like electrons and whatnot? Say in a DC circuit, or in a it would be better if I drew this out on the board. Is that all right?
How about I just explain?
Yeah, sure. Might as well.
It's got to do with the Hertz wave.
Is it because the sine wave, the spike is higher with AC?
It's because it's heading, with AC, it's heading back and forth a little bit. Meanwhile, with DC, it's heading.
Voltage versus time. Right?
Mhm.
What kind of voltage is that?
Direct.
DC.
Mhm.
Okay.
That would be AC.
Okay. Well, frequency kind of is irrelevant. The higher the frequency is, the easier it is to get it to move. But, what is that value?
Average. Constant. Maximum. Yes. Oh, I wasn't good with that.
Anybody remember that?
Medium square, what we're calling again.
Root mean square. Root mean square.
Root mean square, that's right.
What is RMS voltage? How is it defined?
I struggled with this back in the other class.
Do you remember?
I was going through my encyclopedia of my brain to try to find. I keep thinking of the.
I haven't had that class.
Well,
Square would be like your square root.
RMS voltage is defined as voltage that will produce the same amount of heat in a circuit, a purely resistive circuit, of the same or equivalent DC voltage. Okay? Anybody remember what the formula is? Get RMS to peak. No, just learned this last semester. Not all.
I know they're insane. I have one on Google.
Or root two.
That happens to be square root 2 here.
Times 1.1.
Peak is RMS times 1.414, or you can divide by the reciprocal. So both of those will give you the same answer. Multiply by 1.414 or divide by 0.707. Multiplying by 1.414 gives you a better idea. You can picture that better, easier, most people. So it's almost 1.5 times whatever the peak, or whatever the RMS value is, the actual peak of that sine wave. Okay? So what's 500 times 1.414?
707. 707.
500 times 1.414 is 707. Notice that each one of those is just about 1.5 times. AC rating, sorry, the DC rating is about 1.5 times what the AC rating is.
And why did we decide that was why the DC is more? Is the RMS? Oh.
Yeah, this AC number that they're giving you is an RMS value.
Oh, I see. Gotcha.
So the actual peak is in this range at that AC voltage. A little less than that, but.
Okay. Tracking.
Okay. Foot protection, that one actually has the metatarsal guard that goes all the way up inside the shoe, but OSHA standard 1910.136 says the employer shall ensure that each affected employee uses protective footwear when working in areas where there is a danger of foot injuries. This includes electrical shock hazards, reinforced toes, metatarsal guards, and insulated. And they typically have soles that are oil resistant. It says that the employer shall ensure that each affected employee uses protective footwear. That means that the employer is responsible for you having the shoes on. It may or may not mean that they're going to pay for them. Back protection, proper lifting procedures. Stand as close to the load as you can, squat down, grasp it, however you need to, and lift with your legs, not with your back. Back when I was in high school and in much better shape. I know round is a shape, right? I could press with my legs 300%, 350% of my body weight. Can you imagine me trying to pick up me 3.5 times just like this? I'd never stand up again. Think of your back as a lever with the fulcrum in the center. It takes 10 pounds of pressure to lift a 10-pound object. When you add the average 105 pounds of a human upper torso to shift the fulcrum to one side, it actually means or takes 1,150 pounds of pressure to lift a 10-pound object. Putting a lot of strain on your back just picking up a gallon of milk. Always live safely. If it was too heavy, ask for help.
I should really hit the gym then, huh?
Yeah. You got the little electric bolts there, but that is what they describe as a backfire. You injure your back doing something like that, and it feels like it's on fire. Fire extinguisher classes, 5 of them. A, ordinary combustibles, which is wood and paper, any cellulose material. B, flammable liquids such as liquid, grease, oil, that sort of thing. C is electrical equipment, motors, transformers. D is combustible metals, titanium, magnesium.
I forget that.
If you have a magnesium fire, even a Class D extinguisher that is specifically designed for it will have difficulty putting it out because it actually self-oxidizes. Class K is for commercial cooking grease. So over, you can see the hoods over the commercial deep fryers at like KFC or Long John's or wherever. And they got the sprinkler heads inside of them. It's not spraying water.
Water,
Water
grease.
and hot grease just don't go together. Yeah. Most extinguishers are ABC rated, so they're good for any of those three. But need to make sure that if you ever need to use a fire extinguisher, check it real quick, make sure that it is designed for use on the type of fire that you're trying to put out. Because if you use the wrong one, you can make it worse and potentially cause an explosion, which is going to do nothing but hurt you and damage the stuff even further than the fire would itself. Electrical shock, over 1,000 people every year killed by electric shock. Results from any time a body comes or becomes part of an electrical circuit. Class A GFCI, ground fault circuit interrupter, trips at 6 milliamps. In a really short period of time, too. So, body effect, slight sensation at the points of contact. Men on DC, 1 milliamp.
DC.
60 hertz AC, 0.4 milliamps. 10 kilohertz AC, 7 milliamps. For women, it's 0.6, 0.3, and 5.
When would you ever come across 10 kilohertz? That's low. What is that?
Special use case.
Why is there a difference between the men and women?
I was going to ask you
Size
that same
difference?
question.
I kind of assume the size difference. Then again, you wouldn't put it on men and women, you put it on the size. What do I?
Anybody have any thoughts on why it is easier to electrocute a woman than it is a man?
Yeah, higher fat content, higher moisture. Just, you're gonna get zapped harder, quicker.
It makes sense, makes sense.
Body composition is different. It also depends on the path that the electricity takes through your body as to how severe the injury is going to be. You guys that were in class with me last semester remember me telling the story about standing on the scissor lift skyjack and sticking my hand in a 400 amp, 480 volt three-phase bus bar once. Now that is the type of mistake that you only make once. Fortunately, I got my hand in the bus bar, so two of the phases hit me across the hand. And because I was standing in the skyjack and it had rubber wheels, I was insulated from ground. Otherwise, I probably wouldn't be standing here talking to you right now. But it still felt like somebody hit me in the shoulder with a sledgehammer. And, not a 6-month-old baby, but, Mike Tyson.
Yeah, that sounds scary.
Yeah, it
What are you
hurt.
trying to do, replace the fuse in it?
No, I was actually pulling low voltage wire into that same,
Oh, I see,
Panel.
in that camp.
I have a water jar.
Lockout, Jay.
safety guards. All safety guards are designed and installed to prevent accidents. The do not help. They do not help the machine operate at all. They are designed to prevent workers from coming in contact with danger points of the machine. So if a machine has a guard on it, it is there for a reason. It is to protect you because people are stupid. And if you decide to remove or adjust the guard and you become injured as a result, the employer is no longer liable.
Sticking your hand on a roller. Saw that.
Just stay still.
As long as the guard is in place and properly adjusted, if you get hurt, it's their responsibility. If you move or remove the guard, it's yours.
You can almost treat the guard as something to not touch, quite like the thing that's an actual hazard.
Well, the guard is there to keep you from touching the bad stuff.
Of course,
Touching the guard itself won't hurt you.
of course.
But yes, you should still not touch the guard.
Yeah, well, touch the guard, okay. Move the guard, bad. Unless, when you touch it, whoever installed it forgot to tighten the fasteners on it. It moves by itself. Typical enclosure around the gear assembly. Keeps you from getting into pinch point.
Oh, I can picture the worst.
Closure around fan blades. You ever seen the old, like 1940s, 1950s television, Leave It to Beaver and Andy Griffith and stuff like that? They had the fans, they had the wire guard on it, and you could like stick your whole arm through it.
I'm pretty sure I had one of those when I was a kid.
Metal plates and all.
And you survived?
Well, I didn't stick my arm in it.
So, yeah, the guard is, on the fan nowadays, you can't even get a finger through it. So,
But I'll be damned if those kids don't try.
yeah.
I know I tried when I was a kid. Luckily, I had one of the safer ones.
Closure around saw blade. I still have a scar on this finger right there. When I was in Lovecraft Junior in high school, my advanced woodworking class, I was ripping boards I made my mom a dry sink, put living room. And I wasn't watching what I was doing as I was guiding my boards through. I was holding the front of it down with this hand and pushing. I had the push stick. I was safe. But like that, my finger was too low and the blade nicked the finger. Still got the scar. I can't feel it either.
I got one
Right there.
bandsaw doing the same thing. Shot.
Doesn't take long, does it?
No.
You should be able to click on that play button.
I'll get the winner. No way, dude. No way I'd do that. No way. Here. It's when you feel stuff. I'm gonna pick my middle finger. I don't care, dude, that's still.
How does the machine even detect if it's a piece of wood versus a finger in there? I think I missed that.
Said the wood is not conductive and your finger is.
Oh, that's right. Yeah. Yeah, okay. That's nice. That's nice to know.
Okay, moving parts. Before you remove a guard, make sure you have removed the power and the guard portion of the machine has come to a complete stop.
Lockout, tagout.
Yep. Lockout, tag out, block out. Well, design guards prevent accidents without interfering with the operation of the machine. Watch out for pinch points or places where rotation objects meet, pass close to one another. Any place that is moving like that, that are, especially when it's close to something else, pinch hazard, crush hazard, that kind of thing. You also want to make sure that the biggest no-no that he's doing right there is wearing a necktie. And he's rotating or whatever, grab your necktie, and next thing you know, you're doing kissing in front of the machine or whatever.
Kissing the front of the road, all nasty.
Yeah. So, actually, the rules state that you're not supposed to wear any jewelry. There are some people that have silicone wedding bands that they use, typically in weightlifting. It's too easy to crush a gold band. This is not gold, by the way. It's
Titanium.
I guess titanium. Yeah. But no long sleeves unless you have them rolled up like she does. No loose-fitting clothing. If you have a tail on your shirt, make sure it's tucked in. Anything that can be grabbed hold of. She's got pretty long hair. It would have to be tied back at a minimum, preferably secured in like a bun or, hair clippy or whatever. Closure around the belt drive, very similar to that around the gear drive. Punch press enclosure, the point of operation is there where the punch meets the die. All this guarding around here, you probably wouldn't be able to get your workpiece in there unless it was like, a piece of sheet metal. So you got to be really careful in a situation like that whenever you have guarding around a punch press, because the workpiece may be big enough, so you have to move the guard out of the way far enough that you can still get your hand or whatever in there and get it smashed or injured or whatever. Guard openings. Openings of a fixed guard must be designed so that they prevent exposure to the hazards. For example, within 1.5 inches of the danger zone, openings must be 1/4 inch or less. If 32 inches away, the openings can be as large as 6 inches. It's how far in can you reach. Not too many people have 3 foot long arms. You ever seen one of those? What's known as a gotcha stick. If the stick can reach the hazard, so can you. And you see it's graduated. The farther away you get, the bigger the opening can be. So the gotcha sticks usually stop right there. So you don't have to carry around the thing that's 6 inches wide.
Uh-oh. Oh, this is
Damn sick.
They got it on record.
Oh my gosh.
This, by the way, is not pretty.
I saw one where this little guy got caught in a lathe.
Oh!
You look so happy. Who? What? Jesus Christ.
Jeez.
Is he dying?
Hey, what you doing?
Is he unconscious? What was the goal?
Human pretzel.
There's a lot of these videos overseas
Yeah.
where they don't have OSHA.
Oh God, this is live leak.
Yeah.
Oh, that just now hit me. I did not spot that.
Apparently, that conveyor that he was standing on, the top of the conveyor comes towards you. And when they turned it on, down he went.
So that one was late.
Believe it or not,
On a minute.
he survived that.
I mean, I guess you can kind of tell a little bit, but.
He was,
I was working night shift.
he pretty jacked up, but he survived.
They were doing safety. You got the video of it.
That's what they had.
And then suddenly the conveyor belt goes back on.
That's what I was just saying. Just watch it all. I mean, I don't see any blood on him, so.
Yeah.
Could be on the other side, though. I don't know.
I think I saw something on his head.
Did you notice that his pants are way down here?
Yeah.
Not only does it hurt, it's embarrassing.
I mean, I don't mean to say it like that, but like, better him, not me.
Sure.
Yo, is this foot twisted? Oh, no, it looks fine. It looks all, ooh,
Word.
something wrong with his foot. Yeah, I think he might have got caught in something. I mean, better his foot than his face.
No more soccer for him.
It's called his football.
So they gonna hop him off that conveyor, or?
Yeah.
I'm sure he's not going to toss right
You know, all three of them get balls up.
Oh, yeah.
There's something on
That's, that might be blood. Who knows?
Break up.
Just cut open a little bit.
Look at this, getting off.
Lockout, tag out, saves lives.
Yeah.
It does. It really does. You don't need to tell me that. Actually, you do need to tell me. See,
Yes, sorry.
I had the instructions on it.
OSHA standard 1910.147, the equipment is locked out and tagged out before any preventative maintenance or service is performed. Period. Lockout is the process of removing the source of electrical power and installing a lock that prevents the power from being turned on. That is incomplete. Any source of power. You have electrical power, pneumatic power, hydraulic, spring, gravitational potential energy. There's a whole bunch of things, thermal, that can store energy in lethal amounts. Okay. Tag out's a process of placing a danger tag on the source of electrical power that indicated that the equipment may not be operated, may not be operated until the danger tag is removed. It is legal in very specific circumstances to tag out only. It is 100% all the time illegal to lock out without a tag out. A lock must be accompanied by a tag. And you must lock out when it is possible. Okay. There are some very specific situations where a lockout is not physically possible. That's when a tag is okay. Is it safe? Nope. Tag does not prevent you from turning the power on. It just says, hey, you shouldn't do that. Okay. So if you're in a situation where you tag out only, make extra sure that you can at least see where your tag is. Because he's just all around bad guy, and every time he sees a tag, he's, oh, there's something I can turn on.
Sounds like something I'd do for real. No, I'm joking.
I don't doubt that.
Lockout, tagout definitions. Lockout is an energy isolating device that prevents the equipment control from being energized until the device is removed. Tagout is a warning device, such as a tag that can be securely fastened, ED, not S, fastened to an energy isolating device to indicate that the equipment to which it is attached may not be operated until the energy isolating device is removed. Definitions: affected employee is any employee that is required to use the equipment that the lockout tagout is being performed on. Okay, machine operator. Authorized employee is one who locks or tags equipment in order to perform said service. Okay. Authorized employees are the only ones that are allowed to put the lock on, because there's a very specific sequence of steps that you have to go through to make sure that the energy is isolated, dissipated, whatever, and not just anybody is trained to do that. Everybody has to be trained as an affected employee. Those that are doing locking out, tagging out, have to be trained as authorized. Okay? There are only two people on the planet that can take a lock off, a lockout lock off. First one is the person that put it on there, and the second one is their supervisor. The supervisor is only allowed to do it if the person that put it on there is dead. You know, you put your lock on, and on your way home you get hit by a bus.
Probably a grim day.
Then your supervisor can take the lock off. The only other time is if you leave and forget to take your lock off, the supervisor has to contact you and get your verbal permission. There's a bunch of paperwork to fill out. And then the very next time that you are on premises, you have to go to the supervisor and say, hey, where's the paperwork? And you also have to sign off on it.
Okay, so this seems like the appropriate time to bring this up. May I tell a very brief story?
Sure.
Yeah. My dad lost his finger because lockout tagout wasn't properly performed. And I just want to say, guys, when you're working with a team that you trust, you think they have common sense, you think, you know, nothing's going to go wrong, I'm just going to do this tiny little bit of maintenance, take a minute or two, and you're supposed to be doing lockout tagout, do it anyway. Just follow the procedure, just do it. Because, you know, things happen. They will happen.
And a lot quicker than you think.
Oh, so quick. Just instantaneous. Instantaneous. You're in the hospital, you're off work, you're finding a new job, you don't know.
You're pushing up daisies.
Lockout tagout devices like guarantee your safety.
I guess a tagout, not always, but.
No, tagout definitely doesn't.
If done properly, it should.
If it's tagout only, you're relying on the person to adhere to the rules.
I think it would also be best to also know your team, know who is, you know.
Like she said, that's not always enough.
Of course, of course.
And that tagout device, you notice that it says very, very bold letters, do not operate. And then this lock may only be removed by. And that's the person that put the tag on there in the first place. Okay. The flip side is a place where you can put down, you know, we're doing preventive maintenance, replacing the shaft, you know, whatever the reason why the thing is locked out in the first place. Also notice that there is an expected completion time on there. You know, you can put 10 minutes or, you know, 1 o'clock, you know, whatever the time frame is. But that is not required. Expected completion is not required. The department is not required. Your name absolutely is. A lot of people, these are plastic. A lot of people carry grease pencils with them. So whenever they go to lock out something, they can write down on it real quick what they're doing. Put their lock on. When they get done, all they gotta do is take a Kleenex or rag or something, shop towel, and grease pencil wipes right off. And you'll see your tag is reusable. Lockout device, in that particular case, so that has a single lock on it. That is a regular circuit breaker. That lockout device is specifically designed for locking out circuit breakers. When installed correctly, you can't get it off there without destroying it to turn the breaker back on. Okay. This is an example of lockout tagout procedure. It's a boiler situation.
Ain't that a familiar image?
Mm-hmm. Few of you have seen this before. Gives you every single energy source on that device, on that machine. And when you're going through your lockout tagout, you have to make sure that you hit every one of those. The last one down here on the bottom, thermal energy, 500 degrees or degrees Fahrenheit or more. Only thing you can do, stand around and wait. You have any idea how long it takes a boiler to cool off?
A while.
Depending on how big it is, like Brad said, it could be days.
Takes a day or two for a fireplace to cool off.
It's close by a drain, man.
Well, then you can put it in thermal shock and do bad things to it.
You don't want to quickly change the temperature on anything.